we can start. 42 slides. I doubt that we'll work our way through 42 slides. Let's have a look. What do we got to see here about network infrastructure and documentation? And so what we're going to try and do in this lesson is identify network and cabling equipment, analyze network diagrams, and know how we make them. Now, I hope you can remember that from CP 1000, where we had to do the drawing tools. We did network diagrams with that. So there's lots of drawing tools that you can have a look at for that kind of thing. Operating procedures, inventory management, labeling conventions, business documents. So there's just a lot of stuff here about documents and tracking changes. I hope that you notice in this how the many courses that we have kind of tie together. Some of you may have had a course with me about customer service for the IT industry, and actually there's two of those. There's even in year 3. Where there's a lot of attention paid to service level agreements and to ITIL documentation. So I want you, we may not talk about that specifically in this lesson, but all of these things are related and sort of come to the same or end in bringing us to a point where our networks, our documentation is up to date. It's very easy for us to go in and make changes. The network is stable. All of these things are brought about by a objective and very step-by-step approach to our designing of our network and our recording of our network. And so I hope you get that idea. We did talk about the TIA, EIA, I'm pretty sure in a previous lesson. I don't know if tell me if this is, I didn't talk to you about this lesson, did I? Because it's kind of familiar to me, like I may have talked about it all. Okay, have I given you this? I don't think so, right? No. Nobody in the chat saying?
No, sir.
All right, this is new, right? Okay, so did I not mention in the previous lesson a little bit about TIA, EIA, and about this 536 standard? And then we have Cat 5, Cat 6. I don't know. Anyway, so all of that together, we have this concept of structured cabling. I'm pretty sure that that word we've actually used before, that term we've used, structured cabling. Do you remember in the previous, is it me just remembering making these slides? I don't know. Structured cabling, the idea of horizontal and vertical cabling and entrance facilities and data cabinets. Remember any of that? Any of that have we talked about? I don't know, maybe. Have I not? I am so sure that I talked about this. We started it, but we didn't finish. I'm so sure we talked about this. The demarcation point. Come on, guys. Did I not? The intermediate and the main distribution frame, the intermediate distribution frame. Work it? No? Yes, last class. So how far did we get on this, Asma? I'm sorry. I'm just going to kind of go look through here. I'm pretty sure we talked about we finished the whole thing. Ah, yeah, I remember that. So this is just a kind of a review. There we go. Sorry, it was like a week ago. I'm pretty sure we talked about all that. I remember. Maybe we didn't. We didn't finish, so we got to go back and finish that. Did we talk about this bit, EMI terminating? I think we got about it this far. This is where I think we finished. Page width? Yeah, that sounds about right. So all of that stuff we've talked about, which is good. And that brings us, so the idea being there about the documentation. We looked at, I think we looked at this, Cat 6, Cat 5, different, and the plenum versus the ordinary cable. I'm pretty sure I talked about that with you. All right, so terminating, leaving some space at the end so we don't get crosstalk. I'm pretty sure, Ben, I think we talked about that. Avoiding EMI? No, we did not. Miriam says we didn't. EMI, electromagnetic interference. If you have motors, microwaves, anything that's generating electronic sort of waves is going to interfere possibly with your cable data passing over the cable. So what we try to do is don't put computers right next to the cables. Don't put your microwave next to it. Electric motors, other motors, we keep them away. Now, it might be that you are cabling in a factory, in which case you can't avoid this. You have to put cables next to computers, etc. In which case that you might want to consider a different kind of cable, a cable which has extra shielding in it. So instead of using UTP, unshielded twisted pair, you might use STP, shielded twisted pair, which in addition to the plastic insulation, it was going to have around the inside of the outside, wrapper is going to be some kind of metal to shield it. We finished the whole thing? Really? I did. It's there. All of this we talked about? We got to the summary. Oh my gosh. So this is going, I don't have chapter 3 for us. I can pull it out though. So yeah, all right. So we did cover it all. My apologies, students. I'm sorry, it's just not being a great day for me today. So apparently we covered all that. I thought it seemed familiar. Last class we covered it all. So my apologies for that. What I'm going to do is so we're kind of ahead because we're supposed to do chapter 2 today. Looks like we did it last time. So what I'm going to do is I'm going to stop that share and I'm going to see if I can find the other one. Will you bear with me, students? End the slideshow. And let's see if I can find the other one. Open. We'll have a look at chapter 3 if I can find it. So in the Dropbox, I know it's there. Thought that all seemed familiar. All right, so chapter 3. Let's continue on. As I said, I thought that. My apologies, students. Okay. So back to, so Miriam says we've finished it all, and that seems reasonable. So let's look at chapter 2. Let's not waste our time not doing anything. Let's go to the Zoom meeting. And Zoom, where are you? Not there, here. Oh, here we are. So I'm going to share again. All right, my apologies, students. Let's go to chapter 3. We had a little bit of a revision of chapter 2. So let's go and have a look at chapter 3. Addressing in networks. All right. So on the screen here in the college, it's full screen, but it's not full screen in my notes. I mean, for sharing. Anyways, I will share the page with you later. Let's have a look at this concepts of so MAC addresses. I don't know what you know about MAC addresses, but we're going to look at that. A MAC address is hard coded onto every individual computer device. Then there's these other addresses, which is a TCP IP address, or we just call it an IP address. So when we talk about, remember in the OSI model that we talked about in lesson 1, I think we talked about the OSI model, which has 7 layers. We have the physical layer, which is layer 1. Then we have the data link layer, which is layer 2. Then we have the internet layer, which is layer 3. Then we have transport layer, layer 4. And then above that, we have session and presentation layers. Now, the thing is that with the addresses that we're talking about here, we can actually assign them to a layer in the OSI model. So The MAC address is a layer 2 address, and the IP address is a layer 3. And so the MAC address is a physical address. I mean, there's only one MAC address ever put to every physical device. And so that's kind of burned into a chip when they create it, as opposed to the IP address, which is what we call a logical address. So we're talking about logical and, am I recording? Yes, I am. And we're talking about logical and physical addresses. And so the logical address is an address that you as a network administrator can sort of work with. Now, so some other ideas that we've got there, domain names. We can separate the world of networks into individual domains. You may have in a campus like the College of the North Atlantic, you may have multiple domains within the college, or you may have one. So domains are ways that we put a boundary or between different networks that are working together. Command line tools, that just means that you can go to your, there's a number of commands that you can give at the command line. I'm sure that you've seen that, but we will see it a bit more. All right, the MAC address, as I said, is at the data link layer. There's 48 bits in the MAC address, as it says, which is 6 hex numbers, as opposed to the IP address, which is just going to be 4 decimal numbers or octets. That's IP4. There's IP6, which is a much bigger address. So IP4, we're still working with that mostly. So that's going to be 4 numbers, so 3 dots, 192.128.0.10. Whatever. It's that's an example of an IP address. Our IP address, the maximum number that any one of those can be is like 255. That's for that IP address is IP4. The MAC address, as it says there, 48 bits. If you did, so a bit is either a 0 or 1, so it's base 2. If you did 2 to the 48, that's how many different numbers that you could have for MAC addresses. It'd be quite a lot. Yeah. Whereas for the IP4 address, 2 to the 32, I think it sort of tops out somewhere around the 6 or 7 billion mark, which means that we already have problems with that. We've got too many devices on the internet to use a unique IP address for every one. So we've had to come up with all kinds of solutions for that. So for example, we within a particular network, we have private networks and we just assign IP addresses to them. But the other solution to that is to just come up with a different IP address, one that has a lot more bits, 128. So 2 to the 128, that's, yeah. It's even going to be beyond trillions. It's going to be, I don't know, gazillions. Anyways, that will certainly cover us even for our Internet of Things. Now the transport. So this is addressing, right? We're talking about addressing. So the MAC address, we have a physical address at the data link layer. When we get to the transport layer, we have port addresses, which can be used for with the protocols that we're using. So if we want to access a particular protocol, we will actually mention a port address for that. Okay. Computer names. Okay. At the application layer, we're going to have other special names, like as it says, a fully qualified domain name. So we've got. I hope you see what you should get out of that slide is that we have a number of sort of layered ways of addressing things on a network. Every device has a MAC address that's fixed. We never change that. We do have IP addresses at layer 3, and we change that. That's something that we can do. Likewise for transport and port numbers, that's something that we have control over. We decide what protocol we're going to use, and when we decide that protocol, we use the correct port number for that. Now that port number is not a port like a physical port on your computer device. It's referring to a particular protocol. So yeah, okay. So MAC address has two parts, as it says. I don't know if you've heard this stuff before. Right now, I haven't given this lesson to you before, but have you heard this before? You know about MAC addresses having yeah, when? I mean, maybe you did 1101 or something, or 1106. So maybe I shouldn't spend too much time on this. You guys all know all this stuff. Oh, sorry? 1206. CM. Yeah. CM. All right. Let's go through this quickly then. This is some kind of radio. I guess it's probably a NIC, network interface card. It's got a radio antenna on it, but I don't know if it's got an Ethernet link to it or not. But in any case, it's got its own unique idea. You can't see it? Oh. All right, so it's presenting differently to the people in class. My battery's going low, so that means it's not turned on. It's presenting differently to the people in class than it is to, so why is that? All right, so I have this present. What do I have to do? What if I stop the share? Okay, so the thing is that the people here in the class, what they're seeing is they're actually seeing chapter 3 there, but they're not, cannot minimize Zoom when you're recording a meeting. Okay, so bear with me, students. I'm going to stop the recording and I will come back to recording in a second. All right, so let's stop the recording.